So in this problem, we got a sea at the zoo, swims around a circular pool, measured meetings, time is always positive, and this is the acceleration. If the initial velocity is 0.5, determine the velocity vector. Well, when I know these, I know that if I have the position vector, if I derivative that, I get velocity. And if I derivative velocity, I get acceleration. So if I go backwards this way, the integral of acceleration gives me velocity. Integral of velocity gives me the position. So I want to do the integral of the acceleration. So the velocity is the integral of acceleration. So if I look at this x value, I'm going to let u be t over 2. So du is 1/2 dt. And recognize that I'm trying to do negative 5/2 cosine t over 2 dt. And so I don't, this half is here and here, so I can get rid of those and say negative 5 cosine u du. And if I do that, the integral of that is just simply negative 5 sine u plus c. And I can plug the t into there, and so I get minus 5 sine t over 2 plus c1. And similarly with the acceleration, I know sine will give me cosine t over 2. The 2 will go away, but I change the sign because the derivative of cosine is indeed going to be negative sine plus c2. Now, I know that this here has to be 0.5. And so if I solve for that when this is when t equals 0. T equals 0. So minus 5 sine of 0 plus c1 equals 0. Sine of 0 is 0. So c1 is 0. 5 cosine 0 over 2 plus c2 is equal to 5. Well, so this is 5 plus c2 is 5, and so c2 is also 0. And so then my velocity vector is minus 5 sine t over 2 and 5 cosine t over 2, and both the c's are 0. So if I want to find the speed, the next part is asking for the speed of the seal. That means I'm going to take the magnitude of the velocity vector. So the magnitude is going to be the square root of minus 5 sine t over 2 all squared plus 5 cosine t over 2 all squared, which is going to be the square root of 25 sine squared t over 2 plus 25 cosine squared t over 2. I can pull out the 25, which leaves me with sine squared t over 2 plus cosine squared t over 2. And I have to recognize that this scenario here, this here, is my identity, and that's equal to 1. And so it's just the square root of 25, which is 5. So my speed is 5 meters per second is how fast the seal is moving. Continue along. Determine the first time the seal's swimming perpendicular to the vector 2, 1. Well, if I want to go perpendicular to the vector, right, when he's swimming perpendicular to the vector, I'm going to take the velocity, which is like the speed plus the direction he's traveling. And so I'm going to take this velocity vector, sine t over 2, 5 cosine t over 2. And if I'm going to make it, I want it to be perpendicular to 2, 1. That means the dot product, the scalar product, must be 0. And so that gives me negative 10 sine t over 2 plus 5 cosine t over 2 is equal to 0. And I am, in order to solve this equation, I'm going to graph it. And so you have to just trust me that t will be 0.927, and make sure your calculator is in radians. Calculus is always done in radians. Okay, as we continue through here, the next question then is saying, well, we figured out when it's perpendicular to the vector. It says the seal starts, if the seal starts at this position, determine the position vector. Well, the position vector is going to be the integral of the velocity vector. So my position vector, r of t, is I'm going to integrate the velocity vector, which will be, if I take the, I can see it's here. So if I integrate that, I know it's going to be cosine t over 2. Notice the angle stays the same. And last time I had to multiply by 2 to find that coefficient. So again, I'm going to multiply by 2. And so it's going to be 10. And this is going to be positive because going to cosine. And then similarly, this cosine will go to sine t over 2. And again, it's going to be times 10 plus C3 plus C4. And I'm told that it equals to, if I remember what's it say, it is equal to negative 10, 0. So doing the x value, I know 10 cosine 0, because it's the initial value, plus C3 is equal to negative 10. And so that means 10 plus C3 is equal to negative 10. C3 is equal to negative 20. Similarly, 10 sine 0 plus C4 is equal to 0. Well, C4 equals 0 because this is 0. So my position vector is going to be 10 cosine t over 2 minus 20, and 10 sine t over 2. That's my position vector. Now, a couple things I want you to recognize. So one of the things that I know is, like, when I have sines and cosines, this is defining a circle. And 10 is the radius of that circle. So I can read that this is just a circle of radius 10, knowing that it started at the point, if you recall, it's going to start at the point negative 10, 0. So the next question is asking us, with justification, determine if the seal is swimming clockwise or counterclockwise. Okay, so let's look at our position vector we have. This is our position vector. And so let's see when t equals 0. Well, when t equals 0, I know I am at the point, starts at the point negative 10, 0. And we know that this was my initial starting point when t equals 0. So let's try a value when t is pi. So when t is pi, I take pi, I substitute in here, and so I get 10 cosine pi by 2 minus 20, and 10 sine pi by 2. Okay, I know from my trigonometry that this top value is going to, cosine of pi by 2 is 0, so this is going to be negative 20. The sine of pi by 2 is equal to 1, so this is going to be 10. So I'm going to have the point negative 20, 10, which is up here, negative 20, 10. And so I know it started here and it went to here. If I would do t is equal to 2 pi, if I would plug it in, I would end up being over here at negative 30, 0. And if you don't believe me, try it out, and you will see that it's going in this direction. And that direction is anti-clockwise. Okay, the last part of this problem is asking us finally to determine the circumference of the pool. Well, I can see that from here, that diameter here is 20, so the radius is going to be 10. I can also get that from the equation that those tell me the radius. So circumference is equal to 2 pi r, so 2 pi times 10, and so I get 20 pi is the circumference of their pool.